Hi, sixth grade. Today we're going to be talking about liquids. And so let's go ahead and just kind of preview our reading for liquids. So how do you describe a liquid? So you need to think back. Think about how you described a liquid when we were first making observations of them with our states of matter and bubble activity. We're also going to be talking about the particles in a liquid. So I'm going to think about what are the particles in a solid like, because I kind of want to start to compare and contrast how solids and liquids, their particles are the same and different. I also noticed that we're talking about, definite and indefinite, things like that. The shape and the volume. So think back to solids, and now let's think about liquids. And then we have a few properties of liquids that we're going to start talking about: surface tension and viscosity. And those are the two pages that we're going to be taking notes on today. So let's start off talking about a liquid. How do you describe a liquid? Without a container, a liquid spreads into a wide, shallow puddle. Like a solid, however, a liquid does have a constant volume. A liquid has a definite volume, but no shape of its own. Figure 3 shows equal volumes of iced tea in two different containers. The shape of a liquid may change with its container, but its volume remains the same. Let's stop and talk about this here. So, each container contains 300 milliliters of iced tea. The iced tea here, it looks like the shape is different, and it is because our containers are different. But the actual size of the liquid is the same. It just looks like this one, there might be more liquid because it's taller, but notice it's thinner. Whereas this one is wider, but it's shorter. So while the shape changes, the amount of liquid here is still the same. It didn't change pouring from the glass when I poured it in here or poured from here into the glass. And a lot of your groups figured that out when you were doing the lab activity in the back. You would measure out 200 milliliters in the one graduated cylinder, and then you'd pour it into the beaker, and it was still about 200 milliliters. So it's very important that we add that information here. We have a definite volume, so the volume always stays the same, but when we change the container of the liquid, the shape is indefinite, or it's not the same. So let's add that to our notes. Liquids have indefinite or not the same shape, have definite volumes. Okay, let's move on here. Particles in a liquid. In general, the particles in a liquid are packed almost as closely together as those in a solid. However, the particles in a liquid move around one another freely. You can compare this movement to the way you might move a group of marbles around in your hand. Like the particles of a liquid, the marbles slide around one another but still touch. Because its particles are free to move, a liquid has no definite shape. However, it does have a definite volume. These freely moving particles allow a fluid to flow from place to place. For this reason, a liquid is also called a fluid, meaning a substance that flows. Now, I'm not going to get hung up on this term, this vocabulary term, fluid. If you want to remember that it's a substance that flows, that's important, but it's not something that I'm going to be quizzing you over. What I really want to focus on, the particles in the liquid. How are they moving? So you can see they're able to actually slide past each other and move. Whereas in the solid, they were stuck in their place kind of. But they still touch. So they're close together, but they can move some. And I have a better picture to show you. It's kind of a video. So we said the little spheres that you're going to see, they're going to represent water molecules. And the molecules are in constant motion. The attraction of the water molecules they have for each other, they keep them close together. So they can move past each other, but their attractions keep them from moving far apart from one another. So here's our liquid, our water, when we zoom in. So see how they're actually moving around, so they can move past one another, but they still stay somewhat close together. So here's another picture. See how there you might see little lines? So if you have to draw it, you want to draw lines to show that they're actually moving. Now, watch this. We talked about how the water molecules are attracted to each other, and the water molecules are so attracted to each other that even after the balloon pops, the water molecules will stay together, keeping the shape of the balloon. So we have a high-speed camera. Watch what happens. Even though the balloon is popped, it still seems like the water's keeping its shape. But you can see that it's slowly changing as it falls into a different shape there. And we're going to talk about in a minute why the water does this. Okay, so let's go ahead and go back and let's add to our notes. The arrangement of particles. Particles can move, or let's put, I like the word slide better, can slide past one another, but are still close together. And we have some important properties of liquids that we need to look at next. So the properties of the liquids, you're going to actually notice that we have some things here that allow us to have that balloon do that cool thing that we just saw in the video. One characteristic property of liquids is surface tension. Surface tension is an inward force or pull among the molecules in a liquid that brings the molecules on the surface closer together. You may have noticed that water forms droplets and can bead up on many surfaces, such as the leaves shown in Figure 4. That's because water molecules attract one another strongly. These attractions cause molecules at the water's surface to be pulled slightly toward the water molecules beneath its surface. Due to surface tension, the surface of water can act like a sort of skin. For example, a sewing needle floats when you place it gently on the surface of the water, but it quickly sinks if you push it below the surface. Surface tension lets an insect, called a water strider, walk on the calm surface on a pond. So let's add this property to our notes. Properties of liquids. Surface tension. An inward force, tension. Inward force or pull among the molecules in a liquid that brings them closer together. I cannot type today. There we go. Now, you are going to have an investigation that you get to do a surface tension. So while this might not make the most sense right now, it will make more sense once you do that investigation. Let's go back and read the next characteristic. Another characteristic property of liquids is viscosity, or a liquid's resistance to flowing. A liquid's viscosity depends on the size and shape of its particles and the attractions between the particles. Some liquids flow more easily than others. Liquids with a high viscosity flow slowly. Honey is an example of a liquid with a very high viscosity. Liquids with low viscosity flow quickly. Water and vinegar have relatively low viscosities. So I need to add the word viscosity. It's our other property. And so a liquid's resistance to flowing. And so it's how the liquid doesn't want to flow. And so this always gets confusing. A high viscosity flow slowly. A low viscosity means liquids flow quickly. And examples of these would be high viscosity would be honey, low viscosity would be water or vinegar. And you're also going to be able to do an investigation with viscosity as well. So this ends our notes on liquids. What I would suggest that you do right now is you would pause your, quit taking your notes. You can complete your graphic organizer or that section on liquids. Then you can make your liquid concept card, and then you can actually go ahead and do your investigations on the surface tension and the viscosity.